In this video, we are going to go over lesson 8.4, and this is about comparing linear functions. Okay, remember a linear function is represented on a graph as a straight line that passes the vertical line test. Okay, it has a constant rate of change, and if you're given an equation, it's in the form y equals mx plus b. Okay, so our objective today is I will compare the rate of change and initial values of two different functions. All right, so let's look at example number 1. Example number 1 says function A and function B are linear equations. Function A is represented by the table of values, and function B is represented by the equation. And the questions we want to answer is which function has the greater rate of change, and then letter B is which function has the greater initial value. All right, so to figure out which one has the greater rate of change and the greater initial value, we have to look at the functions here and find the rate of change and the initial value of both. So first, let's find the rate of change of the functions. All right, function A, here we have, when you find the rate of change of a function, remember when you're given a table, the rate of change when you're given a table is the change in output over the change in the input. Okay, and here our x is our input and our y is our output. All right, and now we have to find the change in output over the change in input. All right, so these are all, when you look at a table, remember, you can look at a table of values and think of it as ordered pairs. This ordered pair is 1, 2. This ordered pair is 3, 10, 4, 14, and 7, 26. And they told us that these are represented as linear equations. So if you were to graph these points on a graph, this would be a straight line because it's a linear function. All right, so these are all points on your graph. And if you think about it, the way that you find the slope or the rate of change on a graph is you check the rise and the run between any two of the points. So we have to check the rate of change, which is the slope, right, between any two of these points. All right, so let's check the rate of change between the first 2 points. We have, if we had 1, 2, and 3, 10, we have to find the change in output over the change in input. So the change in output between the first 2 ordered pairs is, well, if you go from 2 to 10, you add 8. And if you go from 1 to 3, you're adding 2. All right, so the rate of change between the first 2 points, it would be 8 over 2, which is 4. Okay, since this is a linear equation, right, this is a linear function, the rate of change between any 2 points, the slope between any 2 points is going to be the same, and I'll prove that to you. Let's check the next 2 points in our table of values. We have 3, 10 and 4, 14. So the difference when you go from 10 to 14 is you add 4. That's the change in output. And then when you go from 3 to 4, the change in input is you're adding 1. Okay, so if we calculate the rate of change, which is the change in output over the change in input, it's 4 over 1, which is also 4. So notice so far the rate of change is constant. Now let's check the rate of change between the next 2 points. We have 14 and getting to 26. Okay, well, to get from 14 to 26, let's say we didn't know off the top of our head how to get from 14 to 26. You could subtract 26 minus 14 is 12. All right, so to get from 14 to 26, you add 12. And then to get from 4 to 7, you add 3. Okay, so now let's, again, we're going to do the rate of change is the change in output, which is 12, over the change in input, which is 3. Well, 12 over 3 is 4. So we just proved that this is a linear function because the rate of change between any two of the points, meaning the change in output or the change in input, is 4. It's the constant. All right, so the rate of change for this function, function A, is 4. And we need to figure out which function has the greater rate of change. So function A, we just figured out, has a rate of change of 4. Now let's check the rate of change of function B. Well, we know that the rate of change is the slope, right? Slope is the rate of change. Okay, and the slope of this equation, the number with the x, is 3. So that is your rate of change of this function B. All right, so now we can compare the rates of change. We found out that that function A had a rate of change of 4 by calculating it, and then function B had a rate of change of 3 because the slope is 3. So which function has a greater rate of change? Well, function A, because 4 is bigger than 3, right? So function A has a greater rate of change. Oops, I forgot to put the A. Function A has a greater rate of change. Don't forget that. There's an A right there. Sorry, guys. All right, now we have to check which function has the greater initial value. Remember, the initial value is just like the y-intercept, right? And the rate of change is like the slope. Right, so now we need to find the initial value, which is the y-intercept. Okay, so function A, well, we know that when we're given a table of values, the way that you find the y-intercept is when x equals 0, right? When you have a table of values, the initial value is the y value when x equals 0. Right, because an ordered pair is a y-intercept is always has an ordered pair like 0 comma something. Well, wait a second. Our table doesn't have the number 0. Well, we're going to have to extend the table this way then, right? The x value, we need when the x value equals 0, what's going to be our y value? And we have the x value here is 1. We don't have a 0. So we have to extend the table up this way. If we go to the number 0, right? If we made our x value as 0, okay, we'd have to go from 0 to 1, which would mean we would add 1 to go from 0 to 1, right? You have to almost like go back 1. Well, if you go back 1 on the input column, how many do we have to go back to get to our y value? Well, let me check all my numbers here. Here's one where we went back 1 from 4 to 3. And we know that the rate of change is 4. So when you went from 4 to 3 here, when you went back 1, we went back 4 on the output side. Which means up here, we have to go back 4. We have to subtract 4. 2 minus 4 is going to be -2. Right? If we were to go from -2 to 2, we would be adding 4. And if we went from 0 to 1, we'd be adding 1. So we kind of had to extend the table using our rate of change. So when the x value is 0, the y value is -2. So that initial value, the initial value of function a is -2. And then the initial value of function b is, well, the y-intercept, right? The initial value is the y-intercept. The y-intercept of this equation is 4. It's the number, not with the variable. So the initial value is 4. All right, so let's compare which one has, the question is asking which function has the greater initial value. It looks like function b has a greater initial value because 4 is bigger than -2. So in this case, function b has a greater initial value. All right, now you're going to move on to trying the got it number 1 before you watch the video.